Welcome viewers, in this video we will see the multi-stack stepper motor. Details about multi-stack stepper motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, multi-stack stepper motor. Normally what we are using stepper motor is called a single stack stepper motor. What is that single stack stepper motor? There will be common stator and rotor for which the poles and teeth are placed. Which means only one stator core and rotor core will be available. In that, stator poles and rotor poles are placed. Only one stator core and rotor core. Now we'll see the cross-sectional diagram of single stack stepper motor. Then we'll go to the multi-stack. So this is the cross-sectional view of the single stack stepper motor. See, this is the rotor shaft. Only one rotor shaft available. This is the outer frame. These are all outer frame. So in this rotor shaft, the rotor poles are placed. Similarly in the stator, this is the stator poles. This is A, B, C is the stator poles. This is a winding. This circle refers the winding. That is so that this is the poles. Winding, due to that the poles are formed. Here 4 rotor poles are available. Similarly here 5 stator poles are available. It's a single stack. Only one stator and only rotor frame is available, over which stator poles and rotor poles are placed. Right. So this is the rotor shaft. Over that rotor poles are available. This is the outer frame and stator core, over which stator windings are placed. Here rotor are having 1, 2, 3, 4 poles available. Here A, B, C, A dash, B dash, like that the stator poles are available. Now we'll go to the multi-stack, new cross-sectional view of the multi-stack stepper motor. So this is the cross-sectional view of the multi-stack stepper motor. Normally we have three stack. Generally we are using 3 stack stepper motor, A, B, C. Right? 3 stack is the commonly used multi-stack stepper motor. See, this is the rotor shaft. In that 3 stacks are available. A, B, C. Rotor stack A. This is rotor stack A, rotor stack B, rotor stack C. 3 different stacks are available. This is nothing but rotor stack A poles, B poles, C poles. Right? Poles of the rotor stack A, poles of the rotor stack B, poles of the rotor stack C. Right? So we can excitation given to these poles separately. Separate control is available. We can operate only this stack A alone, stack B alone, stack C alone, or stack A and B and C, like that. So due to that, we have the small step angle is possible. If you operate excitation given only the stack A, mean we'll get the small step angle, while going to B another movement of small step angle. That's why we are using this multi-stack stepper motor, mainly used for small step angle. Similarly, you see this is the stator stack A, this is stator stack B, stator stack C is available in the common stator frame. So these are all the windings of stator stack A. This is the windings of stator stack B. Similarly C. So this is nothing but poles, right? Stator poles. Stator stack A poles, stack B poles, stack C poles. Right? So 3 different stack available for both stator and rotor. The main use is to get the small step angle. Now we'll see the description based on the diagram. We'll see the description. So the multi-stack motor are used to obtain the small steps, typically ranging from 2 degree to 15 degree. We already discussed for 3 different stack available. 3 different stack are operated separately. Separate control is possible. So due to that, we are getting the small step angle in the range of 2 degree to 15 degree. In a multi-stack motor, the motor is divided into M stack, M number of magnetically isolated sections called as stack along with its axial length. M number of stacks. Now in this diagram what we discuss, having 3 stacks are available, that is magnetically isolated. the M stack of stator have a common outer frame while the rotor are mounted on a common shaft, right? So the common outer frame, common shaft. The stator and rotor have the same number of poles or teeth, right? Same number of stator and rotor having same number of poles. Now we'll see the further detail. The stator poles in motor are aligned equally with the rotor poles. The stator poles in motor are aligned equally while the rotor poles are shifted by 1 by m of the pole pitch from the one another, right? The stator poles are motor aligned equally, but while going to rotor pole it is shifted by 1 by m of the pole pitch. In order to get the alignment, we are going with 1 by m of shifting. All the stator winding in a stack are excited simultaneously. Hence, each stator form a phase. So, the number of stator phases is equal to number of stator stacks, right? So, these stacks are excited simultaneously. So, how many stacks are available? That much of phases are available here. Now, we'll go to the remaining description. So in generally 3 stack stepper motor are used. The diagram what we discussed also 3 stack stepper motor. In each stack the stator and rotor laminations are provided and they have 12 poles. The poles of the stator are in one line while the rotor poles are aligned from each other by 1/3 of the pitch, right? So the equal number of stator and rotor poles are available. This laminated having 12 poles. Stator poles are aligned in a one line, but the rotor poles are aligned each by 1/3 of the pitch. The various windings in one stack are excited simultaneously. We already did simultaneously we can excite it. When phase A of the stator is excited, then the rotor poles of the stack A gets aligned with the stator poles. Let us consider only phase A of the stator pole is excited, so that it will align with the stack A of the rotor poles of stack A aligned with the stator poles. B and C is not excited, only phase A is excited, right? So due to that what happened? But the rotor poles of stack B and C do not align. Only A is aligned. Now, so due to that we are getting small step angle. Now, if phase A is unexcited and phase B is excited, then the rotor poles of stack B get aligned with the stator poles. Now, what we are doing? A is unexcited and B is excited, so that the poles are aligned with stack B. Thus, the rotor move by 1/3 of the pole pitch. So, we are getting small step angle, that is 1/3. Again phase B is unexcited and phase B is excited. Then the rotor again move by 1/3 of the pole pitch and this process continues. So phase A, then phase B and phase E is excited simultaneously one by one. So that we are getting normally 1/3 of the pole pitch. Now we'll see the step angle, the formula for step angle. So the step angle is, we know that beta equal to 360 degree divided by m into nr. Here m is 3 phases available. Rotor poles are 12. We already discussed 12 poles. So beta equal to 360 divided by 3 into 12, that is 10 degree. So we will get that 10 degree. So we can achieve small step angle by multi-stack structure. So 10 degree is possible in this 3 stack A, B, C. We are getting 10 degree as a step angle. So small step angle is possible in this multi-stack structure. So in this video we discuss multi-stack stepper motor, how it is differ from single stack and how it is excited, what is the construction procedure, followed by step angle calculation we discuss. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.